The argument in item 4 shows that there is a sequence of rigid motions that maps triangle ABC to triangle DEF. Specifically, the sequence of rigid motions that maps AB to DE, followed by the reflection across ED, maps triangle ABC to triangle DEF. And by the definition of congruence, triangle ABC is congruent to triangle DEF. Let's take a look at question number 5. Number 5 asks us to do the following. Justify the ASA congruence criterion. Consider the two triangles below. A. What given information is marked in the figures? B. The proof begins in the same way as in item 1. Since AB is congruent to DE, there is a sequence of rigid motions that maps AB to DE. Draw a figure at the left to show the result of this sequence of rigid motions, and assume that the sequence of rigid motions does not map point C to point F. It says, C. Mark the line segments and angles that you know are congruent in your figure. D. Suppose you reflect triangle ABC across ED. What is the image of AC? What is the image of BC? And why? And then lastly, letter E. When you reflect triangle ABC across ED, can you conclude that the image of point C is point F, and explain? For this section, I am going to give you 7 minutes to work with your table mates on this section, question number 5. Go ahead, pause your video. All right, as you can see in question 5's answer, we stated that AB was congruent to DE, angle A is congruent to angle D, and angle B is congruent to angle E. Then I went through and I drew the triangles as they asked me again, with that line segment of AB coinciding with ED. And then I drew the markings in question. I did the markings that question C asked me to do by marking angles that I knew were congruent and line segments that I knew were congruent. Here's where we get into the proof type-ish stuff. It says, suppose you reflect triangle ABC across ED. What's the image of AC and what's the image of BC? Well, AC is DF because ED was an angle bisector. BC is EF because ED is an angle bisector. Then it asks, can you conclude that point C is the image of point C is point F? And yes, because we know that the image of AC is DF, the image of point C must lie on DF. And since the image of BC is EF, the image of point C must lie on EF. Well, the only point that lies on both DF and EF is point F. So the image of point C must be at point F. On to your debriefing.